The combines are super quiet. They're really efficient and they do a fantastic job. I've hired custom cutters running a different brand of combine and I don't like the job they do. The equipment is good, it's reliable. I just love running red.
There's constantly changing demands in the marketplace for what your combine harvester needs to do. This site offers some unique opportunities in that we have a wide array of test capabilities in one site, along with the people that allow the engineers to participate through the entire processes, not only in the design of the product, but also the virtual validation of the product, the first prototype builds, working hand in hand with our prototype shop, getting feedback on the manufacturability of their designs, and working hand in hand with the test groups, understanding completely the test and requirements criteria, and resolving very quickly and iterating through designs to create the greatest quality product we can make.
The development process here at Case IH for new products is customer driven, pure and simple. We spent a lot of time visiting with our key customers here recently on what changes are occurring down the road. From there, there's a series of iterations that takes a look and prioritizes those needs. It's a series of discussions, proposals, reviews of those proposals until we get it right.
We are standing in one of our virtual reality rooms that we use for product development. With this tool, the product development team can look at the total vehicle, looking at fit up, part functionality, ergonomics. So this helps streamline and shorten the development time. As an engineer gets a wild idea, we can quick sketch it up in a model, put it into this virtual reality room and see how it would fit and interact with the remainder of the machine.
Because we have this cross-functional group of folks developing at this single site, we can turn around design iterations very quickly.
This is the Rapid Prototype Lab, and this is where we take people's computer models of parts and turn them into actual physical plastic parts. Inside these machines, there's a bed of nylon powder which is being heated up close to its melting point, and then we scan across the top of that powder with a laser, which kicks it over its melting point and melts cross-sections of the parts that we're building. Smooth on more powder, center another cross-section, and so on. At the end, you've got your parts embedded in a cake of plastic powder. Brush the loose powder away, and there are your parts.
One of our great benefits here is having engineers and the prototype shop located in one building together. What we do here is we produce parts and prototype machines. The engineers that are located within this building will write a work order and send it down to our shop. Raw material is then either lasered, formed, machined, welded, assembled into machines. The engineers will spend a lot of time in the shop working side by side. They work jointly, hand in hand, to get the product to market faster.
By using what we learn in the lab, we can take and get an early jump on it here prior to going to the field and do the final checkouts on it in the field. We can take and replicate stuff from the field very well with this setup that we have. When we're running in a lab, our units are not moving, so we have to move material to the unit. There's conveyors that we can take and speed up and slow down. We can simulate about any condition that you'd want in the field for throughputs. The customer will see a lot of benefits that will come out of these labs. The lab that we're standing in right now is our CFDL facility, which stands for Cleaning Functional Development Lab. As we take and increase throughput out in the field, if we're running a 40-foot head and we increase ground speed, we're increasing the volume of MOG that's going through the combine as well as the volume of grain that's going through the combine. The environment here, we can make run after run after run and have everything exactly the same from run 1 to run 10 to run 20. For that, we can use high-speed cameras or just visually look. We have glass sides that we can look through and see how the material is flowing.
Our job in the test lab is to break things, and through running our components until failure, it helps us understand where we can go back and make them better. As we look at all the different types of tests that we conduct at this site, and specifically in the test lab area, which is going to be our component and subassembly type testing, all of this work really is the background and is the behind the scenes work that goes into making our products reliable and have a long life in the field. At this site we have about 20 to 25 different test cells. These would include gearbox durability type testing, high temperature testing, performance checks on hydraulic components or hydraulic valves. We also have a cold room where we do cold testing to ensure products are starting at the extreme cold climates and extreme cold environments. Many of these tests will run thousands and thousands of hours, and this helps us to really understand how they're going to respond in the extreme environments that our products run in.
We test the electronic and electromechanical devices used on our vehicles. With HALT, we subject the product to increasing levels of temperature, cold, hot, rapid thermal roller coaster rides, and vibration. When we run a product through the HALT process, what the customer ends up with is a very robust product, because if we can't fail it in the HALT chamber, in my torture chamber, in my time machine, if we can't fail it there, he's going to have a difficult time failing it on the vehicle.
We can test every component and the assembly, but the customer doesn't care about the components and the sub-assemblies. They want the whole combine, a complete system where everything works together. So we take the testing out of the lab and into the real world, and out here we can put the equivalent of about 3,000 hours of wear and abuse on a combine in just a short amount of time. We want to prove that our headers perform in the worst kind of field conditions. There's places where all your acres may be flat or uneventful, but then there are regions where there's hills and terrace, slopes, wet or dry. We want to see the hydraulics, the electronics, the mechanicals, they're all working together. Field speeds are way up from where they used to be, and we don't want our headers being the limiting factor.
During the benchmark process, the basic test that we're running is looking at the material other than grain through a combine as well as the grain through the combine. We've got our processor and collector which is used to hook behind a combine to gather the material that comes out to the combine. That would be the MOG and any potential loss that there may be. We can use this data that we've collected with all this machinery that we have sitting back here to improve our combine by, one, looking at a competitor machine, how good are they? We can look at our current production unit, how good are we? We'll end up having a product that will be much better for the customer. He'll get more grain out of the field, he'll get better samples in his grain tank, and he'll have higher throughput capabilities, and that all adds into dollars in his pocket.
With the Axial-Flow combine, we were able to greatly increase the quality in our corn, and we went from the lower tier of the production base to the top tier of the production base for that company just by switching combines.
It's worth more having a clean kernel and not a kernel that's smashed or damaged, and especially worth more if the kernel's in the hopper and not on the ground.
It's a continuing, evolving process. We don't use near as much energy now to produce crops, and our crops are better, we're growing more bushels, and we're going to have to continue that because world population keeps going up and up, and it's going to be a strain to keep up, but I think we can do it. I think we will do it.